All right, welcome to today's Explainer, where we are going to demystify something that makes pretty much everything you do online possible, the IP address. It's the hidden engine, the secret sauce behind every click, every stream, and every single search you make.
I mean, really, have you ever stopped to think about it? You fire off an email, you start streaming a movie. How in the world does that information navigate this unbelievably vast and complex web to land precisely on your screen and not, your neighbor's laptop?
Well, the answer is a simple but incredibly powerful concept that's the key to all digital communication, and that is the IP address.
Okay, so let's get right into it. What exactly is an IP address? We'll start with a really helpful way to picture what's actually happening behind the scenes. So that's the formal textbook definition, but the key word you really need to latch onto here is every. I mean it. Your laptop, your phone, your gaming console, even that smart toaster you got for your birthday. If it connects to a network, it absolutely needs one of these unique IDs to send and receive information. By far the easiest way to understand this is to think of it like a home address for your mail, right? Your house has a specific street address and postcode, so the Postal Service knows exactly where to drop off your letters. An IP address is precisely that, but for your devices on the internet.
Without this system, it would be pure chaos. It'd be like trying to mail a letter with no address written on the envelope. Data would just be lost. The internet as we know it simply could not function.
But here's where it gets really interesting, and this is a crucial distinction to make. An IP address isn't some permanent tattoo on your device. It's actually a lot more like a temporary name tag. You see, your device actually has two different kinds of addresses. One is called a MAC address, and that one is physical. It's burned right into the hardware at the factory, and it never, ever changes. But the IP address is logical. It's just a temporary label that's assigned to your device for as long as it's on a specific network. And you don't need to get bogged down in the network layer details. Just know they work at different stages to get the job done. Here's a perfect everyday example. Your phone, sitting on your home Wi-Fi, has one IP address. The second you walk outside and it switches over to your mobile data network, boom, it gets a completely new one. Its digital home address changes depending on which network it's currently visiting.
And you've definitely seen this before. This format, these four numbers separated by dots, is called IPv4. Each of those numbers can be anything from 0 up to 255, and this simple structure is what created a massive, massive pool of unique addresses.
And when I say massive, I mean it. This little four-number system allows for over 4 billion unique combinations. Back when the internet was first designed, that seemed like an almost infinite number of addresses. I mean, they probably thought there's no way we'll ever use all of these.
So we know what an IP address is, but how does this digital postcode actually guide your data on its incredible journey across the globe in less than a second?
Well, if we go back to our analogy, and the IP address is the digital home address, then you can think of routers as the super efficient postal workers of the internet. Their entire job is to look at the destination IP address on a piece of data and figure out the best way to send it along on its journey.
Here's a quick play-by-play. Your data gets broken into tiny pieces called packets. Your computer then slaps the destination IP address onto that packet, just like stamping an envelope. It sends it to your local router, which reads the address and forwards it one step closer. The next router does the same, and the next, and the next. It's like a giant, super fast game of digital hot potato, until it finally arrives at the correct network.
But the IP address isn't the only hero in this story. To make that final, precise delivery, it needs a teammate. It's a team sport.
And here's how they work together so beautifully. The IP address does the long-distance hauling. Its job is to get the data packet to the right city, or in our case, the correct local network. But once the packet arrives in that city, the physical MAC address takes over. It acts like the local delivery driver who finds the exact house on the street, your specific device on that network.
This amazing system of teamwork isn't just some clever little feature. No, it is the absolute bedrock of how the entire internet functions.
From the very moment you connect, IP addresses are at work. They are essential for routing, which is just directing all that global traffic. They're used for subnetting, a fancy way of saying organizing big networks. Something called DHCP uses them to automatically give your device an address, and DNS uses them to translate a website name you can read into a number the network can understand. Almost every single thing you do online starts right here.
And that really is the bottom line. It's the elegant, simple solution that allows trillions upon trillions of pieces of data to find their way across a global network every single second of every single day.
But 4 billion addresses seemed infinite at first. But with this explosion of the Internet of Things, billions of phones, watches, smart fridges, cars all needing an address, we're actually running out of digital real estate. We've pretty much used them all up. This has forced the world to start adopting a whole new, much, much larger system, leaving us with a really fascinating question for the future. What's next?